Hi, my name is Jared VµN, and today I'm going to be showing you the point cloud functionality in Tekla Structures at version 2024. We'll be going over attaching a point cloud into our Tekla model, showing how that can be imported, modifying the properties and visualization settings with a model inside of Tekla Structures. So let's get started by going over to the point clouds icon on our side pane on the right. To start attaching these point clouds, we'll just click on the attach button. You can drag and drop your files here or browse for them. So I'll select my structural steel E57 file. If I click on the compatible types, here's just a list of the different file types that you can import in. You can also find these on our Tekla user assistance. So I'll click on open. I'm going to place this point cloud from my base point. So I'm going to select my base point, and if I edit this here, you can create them from this dialog. I just want to show you for this base point, I just have an X, Y, and Z offset, and that's repositioning this point cloud to align with my Tekla model. We can also apply a scale. I'll just leave 1.0 for that, and then I can attach the point cloud. It'll show up in this user interface over on the right, and so I can turn this on or off if I have multiples, so you can choose just to show one or many at the same time. And this is going to highlight there's going to be specific settings for the current view that you're working in. So there could be multiple views, and based off of what you have selected, it'll either show a certain point cloud with certain settings based off of that view that you have selected. So there's a couple other groups of properties here that I want to go over. One being the properties, and this is really basic information. We can update what file is being used for this point cloud. If that file name changes or if it's in a different file location, we can change the location here, update the scale, X, Y, Z, or rotation in the Z. Now, if we go into the visualization settings, this is where we can modify the visual properties of the point clouds, really the visualization of all the individual points in these files. We'll be able to color by different settings like elevation, their classifications, and we can even color by clashes. Now you'll notice these settings right now, they're grayed out, and I'm not able to manipulate any of these properties. The reason for that is if I go into the settings menu here, I have use legacy rendering selected. You want to make sure that DirectX rendering is active. So we want to deselect use legacy rendering if you have that option highlighted. Now if I close this view, I'll bring up my view list and re-show that view. With DirectX active, you'll see that these visualization settings can now be modifiable. So I can adjust the depth perception, or EDL, which is eye dome lighting, and it helps improve the depth. We can also adjust the size and density of those individual points, and there's different options to color the points by different parameters, such as elevation or clashes. Let's go into a plan view I have at 127 feet. Once I select this view, now in the point clouds menu, it'll say settings for view 1, plan at 127 foot 6. I don't have my point cloud shown right now, but I wanted to show you these model objects that I have in this view. So let's turn everything off and let's just show my parts for this view. And now that'll be overlaid with my model. So this point cloud is matching with a structural steel model inside of Tekla. So you can see those points are sort of aligning with the different members, beams, and columns, and any pieces or parts that I have. In the color by section, I want to review elevations and clashes. So let's start with elevations. And with this setting, we'll define a top elevation, a middle elevation, and a bottom elevation. And based off of those values, it's going to colorize the points within those point clouds based off of those values that you define, with the middle value being green, top being red, and bottom being blue. So these beams, the top elevation is 127'6". Now I want to find my contextual toolbar, and let's turn off my parts for now so we can see these points. Now this value that I have set as the middle, that's going to be where this green coloring is, and from either the middle to the top value, the color is going to transition from green to red, and from this middle value to the bottom value, it'll transition from green to blue. So let's change this to just be 6 inches below the middle, so I'll do 127 feet. I'll hit modify. Or maybe we can exaggerate it just a little bit more. We'll have it be 12 inches from this middle value. So the beams, it looks like the top of beam, they are what they're supposed to be, around 127'6". They're showing as green. Now 12 inches below that, it's going to be about right at this location. You can see how that color is transitioning from green to blue. So at this point, everything below this is going to be blue. Above my 127'7", it's going to be red. So that's all for reviewing the color by elevations option. It's a great way just to be able to visualize those points and where they're falling from those elevations, which parts are above or below those specified values that you enter. Now let's review the color by clashes feature. We'll want to make sure that we have a model object selected when we are wanting to color by clashes. If I just click on this button, the appearance of the point cloud is going to remain the same. Once I select on an object, I'll grab this MEP ducting here. Now you're going to see I'm going to start getting a colorization of the points within that point cloud. Now to show that this feature will also work by selecting reference objects, I've modeled in some polybeam in Tekla. I exported it as an IFC to represent that you could bring in reference models from subcontractors or mechanical or electrical or a concrete contractor, bring those in and be able to measure tolerances or clashes with what you've scanned in the field. And we can of course also select on Tekla native objects. Like I could select on this beam, and I could even use this feature to see how closely the steel beam that I modeled in Tekla, how it's matching up with what was actually constructed and scanned in the field. Though the primary purpose of this is to, of course, check clashes, as the name implies, but you can also sort of use these features in your own unique ways too. So I brought in a reference object. It might just look like a Tekla object, but if I turn this IFC on and off, you can see that that is indeed a reference object. So now let's go back to my point clouds group, and let's select that reference object. And now I want to check that this reference model is within my tolerance for what was constructed in the field. Let's say that there needed to be about 1.5 or 2 inch tolerance for these MEP parts. So let's go ahead and show a short example doing that. We can also save away attributes if you have specific types of checks that you want to do. So if I click in the drop down, I have a check MEP tolerances setting. So once I select on that, you'll see that my tolerances are updating here. Well, before I proceed, let's go ahead and turn off my parts in the model so we just have the object that we're concerned with. So I'll highlight that, and now we can just see the points. So in this tolerances section, we can change these colors. So if we want this orange to instead be we'll just make it a lighter red color. We can change those those colors, no problem. We can also turn off points that are outsides of these ranges. So if I just wanted to see points that were within these defined distances here, if I click on the eyeball for this last group, now I'm going to only see points that are within those distances. Now, another trick to help you more clearly see the points is I can show objects as a wireframe. The shortcut for that is Control-Shift-1 for a reference object. I can also find those same options here in the rendering drop-down. So there's references wireframe, components wireframe, and parts wireframe if we're selecting native objects. So that'll help me see through the part. This object that I added in as a reference, this wasn't actually done by a mechanical contractor. I just created it so I could show you as an example with the reference model. So we can see we clearly have some clashes down here. But for this application, I wanted to say, hey, that we needed a tolerance of 2 inches from the top of this duct to the steel beams. And I can even turn all of these groups off so I can see very clearly where we're having issues or where we aren't meeting that tolerance. So I don't have to look through a bunch of points to find where there's issues. I can just clearly see where those violations are. Now these sizes and density, they've already been increased, so I can clearly see these points. What it might look like if you haven't modified these settings, it could be a little tricky to see, or maybe you really just want to have a different representation. Just changing the size and density of those options there in that point section can really help you, have a better visualization of the points and where those tolerances are below or above your ranges that you've defined. That's all for this video. We've given a review of bringing in point clouds, showing how those are attached, modifying the properties and visualization settings, and just a couple different methods of how we can use point clouds with our Tekla Structures model. And don't forget, there is also information on the Tekla user assistance about point clouds. So if you need some more information, please find that documentation in our user assistance and reach out to your local Tekla support team if you have any questions.